All right, students, let me try another video solution. Here is this tough Faraday's law where we're trying to figure out the direction of the induced current. So keep this in mind, what Faraday's law says. It says that the induced current opposes the change. Keep those two words in mind. The first one is oppose. So what we mean by that is if it has a value, say, of 10, it doesn't want to increase, but it also doesn't want to decrease. So notice we're not saying it opposes the flux. That's the common mistake. It doesn't oppose the flux, it opposes the change in the flux. All right? And so that's the key here. So the induced current opposes a change, So there's got to be some kind of change in the flux to even have an induction. Let's see if this one illustrates it here. It says, number 4, chapter 23, it says, referring to this figure, so I went ahead and printed the figure, and B, so I guess this part of the figure. These are for a different question, but referring to figure 2357B, what is the direction of the current induced in the coil? And so in here, in the coil. And notice it's next to a wire that shows a current going upward. It says if the current in the wire is increasing. So let's think about before it starts to increase. Let's just say the current is running at, I'll just put 5 amps. Okay? And then going back a chapter on our magnetism and using the right-hand rule for the direction of the magnetic field, if you kind of imagine me taking my right hand and grabbing the wire with my thumb pointing up, so current's going up, the field, and for whatever reason I like to kind of do the field in a green pen, would be coming up, well, I guess up for me, but for you it would be, out of the screen, wrapping around and going then into the screen. So on this side of the wire, I guess I would put like a little circle with a dot because the magnetic field's coming out. And on the other side, it would be going in. And since Faraday's law has to do with the change in flux in whatever coil, let me illustrate that flux right there. This is the coil we want to study. It says, what is the direction of the current induced in the coil? So what I need to know is before I do this, if the current in the wire is increased. So before I increase it, I need to know that there's already flux going into. And so let me just put like 10 and I'll say into, just to make up a number. I'm not saying the flux is 10, and that's not even the point of this problem to do any numbers, but just to realize that what we're opposing is a change. We're not opposing the fact that there's 10. So there's already 10 there. And the point is we want it to remain 10. And I should say 10 into the screen here, okay? See, because in A here it says if the current in the wire is increased, we're going to go, from 10 into, and it's going to get bigger, 11 into, or even 12 into. Now, when it says it opposes the change, what it means then is the current would be set up in this loop, and in this way it would be either clockwise or counterclockwise, such that it wants to keep the total flux back at the 10. So what that is really saying here is, if you let me use the word primary, is the flux that comes from this wire. The primary flux was at 10, the current increases, and so let's say it goes up to 12. So a current, a secondary current, is going to be set up in this coil. That current will make a secondary field so that by the time you put the primary and the secondary together, we like to remain at 10. So what that really means is if the secondary is coming out, so I'll say out, with, say, a value of 2, the primary increased to 12 into, and then the secondary creates a current of 2 outward, then we're back to what it started at. We're back to 10, and that's what I'm trying to say here. In other words, it opposes the change. So as more flux is trying to go in, the induced current will be in such a way to oppose that change, to keep it at 10, and it would be coming out. And that's the key we need to know, is that the direction would be out from the secondary. And the way you get out, again, going back to last chapter, I could put my thumb representing the magnetic field in a ring, and then my fingers would be going around in a circle in a counterclockwise direction. And so I guess that would be the answer here to A, when it says, what is the direction of the current induced? And so it would be counterclockwise. Okay? And again, that's what we mean by opposing the change. We're not opposing the flux, we're opposing the change. Let's try this again in B. B, if the current were to decrease. Now, it's kind of the same logic. Let me just kind of switch colors there. Maybe it'll stand out. But let's do the same thing. Let's say we already have a flux of 10, and it would be going into, because we have, this wire that is going, with 5 amps. And so let's go back to the beginning. But this time in B, we're going to decrease it. So instead of having 10 going into, maybe it drops down to 9, or maybe even drops down to 8. Now it's still into, but it's a lower number. So a secondary is going to be formed to get us back to 10. And so that means the secondary this time is going to be into the screen. It's going to create a, let's say, drop down to 8 in the primary, so the secondary is going to be 2 into. And so the current in this ring, this coil, is going to be 2, and it's going to be into. So again, using that right-hand rule number 2, I believe it is, from last chapter, we have a coil with a current. I can do this. I can put my thumb into the screen here and look at my fingers, and so my fingers are wrapping around in a clockwise direction. And since we just did A, it's not a surprise that they would be opposite, because again, we oppose any change. So in A, the increased current increased the flux, so we go opposite of the flux to keep it where it was. But in B, we already have some flux going in, and we're decreasing that. So we want to generate a secondary flux that goes into it, again, keeping it at 10. So notice that we're not saying that the induced flux is opposite to the flux that's already there. What we're saying is it opposes the change. It wants to remain where it was, okay? So there's A and B. And then here, see, if the current in the wire suddenly changes direction. Okay, well, again, putting some numbers here, I guess what we'd be saying, just to kind of put some numbers with our thinking here, is if the current was going up and it was creating a flux that is 10 into, and then it was just magically reversed and had the same number. They say the current was suddenly changes direction. But I'm going to just say changes direction and has the same value. All of a sudden, we'll go from 10 into to 10 out. Okay, but again, it wants to go back to where it was, which was 10 into. And so the secondary would make a 20 into, so that when you have the flux from the primary, which was at 10, and all of a sudden now is at 10 out, or was 10 into, and now it's 10 out. To get it a total of 10 into, the secondary must give 20 into. Now, again, I'm just making up numbers here, but the point is it's got to be into. So I'll put in blue here, into. And so again, it's got to be clockwise. And you can kind of see it's going to be the same answer as B, because B was a decreased, and that's really what we're saying there. If you change the direction, you would have to go from 5, and you'd have to decrease it from 4 to 3 to 2 to 1 to 0, and then continue to decrease it. -1, -2, -3, -4, -5. And so to go from 5 to 5 in the other direction is really say decrease it. Decrease it from 5 take away 10, and you get negative 5. So C and D got to be the same answer. They're both a decrease. All right. Again, hope that helps. Just want to emphasize it opposes the change. Okay? The secondary opposes the change. And so keep in mind there must be a change. Because the next one I'll do is 27, and that has some very interesting ones and some insight too. And it's the same physics, but there's some cases where there is no change. And that one didn't really address it here. But I'll do that one in 27. All right, take care.